In this demo, I will demonstrate how to create an Azure Machine Learning compute cluster to utilize your Microsoft for Startups dedicated GPU cluster allocation. Welcome to the Azure portal. I'm assuming in this demo that you've already completed setup steps, including creating a Microsoft account, setting up your subscription, and redeeming your Azure sponsorship credits to pay for your GPU cluster reservation. If you haven't completed those steps, please refer to the Microsoft for Startups GPU cluster FAQ page for instructions and links on completing each of these steps. As you can see here, I'm signed in with my Microsoft account to a demo Microsoft Entrada ID tenant, which is the top of the Azure resource hierarchy folder structure. Entrada ID is Azure's service for identity and access management. The next level down is management groups, which enable you to further manage access and policies. If you're coming from working on AWS or GCP, tenants and management groups correspond to Azure or AWS organizations and organizational units, and GCP organizations and folders, respectively. Azure subscriptions are associated with payment accounts at the next level down and act as a further resource and billing boundary to manage and access resources and costs. These are most analogous to AWS accounts and GCP projects if you're coming from those platforms. Azure also offers resource groups, which act as an additional resource boundary below subscriptions that you can use to manage resources associated with a particular project, environment, or user. Each resource you create on Azure needs to be associated with a subscription and a resource group. Recall for your GPU cluster reservation, you'll be granted quota for Azure ML Compute and Italy North. So as a first step, you need to create a resource group in Italy North for all resources associated with your GPU cluster reservation. So in this case, we're going to navigate to resource groups and create a resource group under your Azure sponsored subscription in Italy North. So there's a couple ways to navigate on Azure. You can always search at the top here in the search bar for the particular service you're looking for by name. You can also look through an exhaustive list in this hamburger menu here on the left. In this case, it's frequently used service, so I have it up here at the top. So I'm going to go ahead and click resource groups here. Go ahead and click create to make a new resource group. And you can see here this is populated with my subscription here. Again, this would populate or make sure if you have multiple subscriptions, you're using that as a resource boundary. Make sure to select your sponsorship subscription here if it isn't already populated. All right, so we're going to do something, create a cluster name like Microsoft Startup GPU cluster, Italy North as a resource group name. We're going to make sure this is in Italy North, as I mentioned. And note, you also have the option to add some additional tags. These can be helpful for cost management purposes. For the purposes of this demo, we're just going to click through to review and create. And you would go ahead and click create once validation pass. And in this case, for this demo, we already have a existing resource group. So I'll go ahead and navigate back to that. So next step is that we're going to create an Azure Machine Learning workspace. And recall this is kind of the high-level container for all of your kind of ML development. So things like your associated data sets, metadata associated with your model runs, all of that gets organized under Azure Machine Learning. So you can see here we have an existing resource or existing workspace that's been created here for demos in Italy North. I'll just show you guys the wizard here real quickly. So go to new workspace. So we have our sponsored subscription. In this case, we're going to do demo. We're going to put this under a resource group previously created in Italy North for cluster demos. And we're going to give this a unique name, something like ML Microsoft for Startups GPU cluster is a pretty good one. And we're going to make sure that this is also in Italy North. And note I mentioned in some of the previous videos that there's dependent resources that get spun up with your Azure ML workspace. So the first is going to be a storage account. So by default, you can either select an existing Azure storage account if you have one, or go ahead and create a new one that'll be associated with your workspace here. So in this case, you can see that it's kind of auto-generating these names for storage accounts. Next is going to be a key vault for things like secrets, keys, and certs. And the next is going to be an application insights logging group. That's going to be particularly important for troubleshooting your Azure Machine Learning jobs down the line. And then kind of this next step that isn't by default, but nevertheless I recommend is going to be creating a Azure container registry. So in this case, you want to go ahead and select create new to create a new container registry here. What this service is going to do is for each one of your job runs, when you create an environment, you can save versions of your environment containers to the container registry. And when you run your first Azure Machine Learning job and subsequent jobs after that, it's going to go ahead and cache your environment images in this container registry for faster subsequent training runs. So rather than, building your environment container every time, this kind of acts as a caching repository for Azure Machine Learning environments and jobs. You can click through, there's some additional settings here for network controls, for data encryption, and controlling identity and access management here, either based on kind of Entrada ID credentials or kind of account keys, or you can use Entrada ID directly to manage users for your workspace. In this case, we're going to go ahead and just leave the defaults and click through here. Like before, you can also include tags for improving cost management down the line as well. All right, so in this case, it's going to go ahead and run final validation here. Once this validation is passed, you go ahead and click create, and that would deploy your workspace. Note that the deployment times for a workspace and some of the associated resources can take anywhere from 4 to 6 minutes. So maybe go ahead and make another cup of coffee while it spins up. And once your workspace has been created, you'll get a notification up here that your workspace has been created. And you'll see a page like this. And from here, we're going to go ahead and launch Azure Machine Learning Studio to create our GPU compute cluster in Azure Machine Learning using the UI. So we'll go ahead and hit here, Launch Studio. All right, so now we're within the workspace, just kind of orienting ourselves on how to navigate around here. You'll see a lot here around notebook samples. This includes links to popular models in the model catalog. In particular things like, Phi and kind of the Llama series of models, if you want to fine tune and deploy there. And it also includes some templates for prompt flow up here. So templates that you can use quick deploy for building generative applications. So including things like prompts and defining your applications in kind of a DAG that you can go ahead and execute for things like evaluation and swapping out different environment variables to kind of control the flow of your application. So highly recommend checking out prompt flow, but we don't have time for that in this demo. So what we're going to do first here is look here along the left ribbon. So I mentioned the model catalog. Authoring is where a little bit of a misnomer. You can spin up kind of a command line utility if you want to interact with a terminal here. Under notebooks, you can also deploy your kind of web-based versions of VS Code here as well. You can see prompt flow here. You can see kind of metadata services or UI controls for interacting with data, looking through your job runs here, interacting with pipelines as well as environments here. So these are, again, going to be your containers that you use for executing jobs. And you can see things like, registering your models for deployments for inference and endpoints, which are kind of the logical construct for combining models and inference compute together for inferencing once you're finished training on the cluster. For now, we're going to jump over to compute here. And you're going to see a couple things here. Under compute, there's compute instances. In this case, this is an instance that I was previously using just for development here. So compute instances refer to just individual nodes. Compute clusters are going to be for multi-node. So the GPU cluster in particular facilitates multi-node training. So we can see here under compute clusters that I have two existing clusters here. One is a GPU cluster with kind of the VM SKU, these ND A100 SKUs that you'll be provided as part of the GPU cluster. And you can see it's in Italy North here, and I was given two nodes for the purposes of demoing to you guys. You can also see up here, just to call out a couple other things up at the top here, you can directly associate Kubernetes clusters as an inference target with your Azure Machine Learning workspace up here. Attached computes refers to if you have a VM that you want to bring into Azure Machine Learning that's supported. Say, for example, you have maybe a single A10 node that you want to use for inferencing. So just, a single GPU type SKU, you can bring that into Azure Machine Learning with attached computes. You also have the ability to spin up serverless instances for training, and in particular, you can also use this to do things like build environment images as well with serverless compute. It doesn't support inference yet, unfortunately, but I do believe that's on the roadmap down the line. So under compute clusters, we're going to go ahead and to start out, to create a compute cluster, you're going to go ahead and click New. Make sure to select some of the following. Make sure that the location is Italy North, that the virtual machine tier is dedicated. I'm going to go ahead and select GPU there. And note here at the top, you should see the quota for the GPU cluster VMs for your A100s populate right up here at the top. If that's not the case, then there might be an issue with the allocation or reservation. So contact Azure support and the MFS DevOps@Microsoft.com to verify your reservation if this isn't appearing here. So we're going to go ahead and click there, click next. We're going to give this something informative, like maybe like AML GPU cluster. And here, I mentioned Azure Machine Learning is built on top of kind of Kubernetes here. It just doesn't expose the APIs. So this is kind of how you can control the auto scale settings for your cluster here. So you can, by keeping this at 0, you enable scale to 0. So this is a great way to manage your compute costs to ensure, if you're not utilizing the cluster, you don't have jobs running against it, that your cluster will scale down to 0 and kind of cease ongoing compute charges. And in this case, I mentioned I had quota for 2 GPUs, so I'm going to go ahead and bump this up to 2. And I always recommend bumping up the idle seconds before scale down. So this controls, again, kind of the auto scale settings. Just by adding an extra 0, you can bump it up to 20 minutes, which I find is probably what's needed for allow you to SSH into any instances for debugging or troubleshooting jobs, or connecting a debugger to your job container there. You can also make sure to enable SSH access at cluster creation. This is something that you can't do later on. Um, so in this case, enable SSH access. I recommend doing this again for troubleshooting purposes. And you can kind of click through here and create an SSH public key here. There's additional settings here for, if you want to run your Azure Machine Learning um, compute cluster within kind of a, VPC or like a virtual private network. And you can also assign a managed identity to your compute cluster. So this is probably a little bit more relevant if you're using the pipelines SDK, but potential use case here for the cluster might be that you enable um, you have an initial job that's maybe doing some data pre-processing, maybe scaling, resizing images, and maybe you want to push that out to a Spark cluster. So by creating a managed identity here, this will enable your GPU cluster when you trigger a job against it to then act on your behalf to go out and execute that job on that remote say Azure Synapse cluster for your Spark jobs. And then from the outputs of that job, it might feed that into a GPU training job that might take place on the cluster. So um, these are just some of the settings and that you have available to you here. So I just want to call those out. And as I mentioned before, for cost management, you're also able to add tags here for greater kind of cost management granularity. And in this case, let's see. Um, in this case, I need to provide specific names here, so you can see once you pass validation here on the left, you can go ahead and click create. In this case, I already had an existing GPU cluster, so let's go ahead and jump over that to take a look at it. So clicking into this GPU cluster, you can see kind of the cluster definition. So it includes everything from resource properties. I mentioned you do need to set up SSH access when creating the cluster initially, but you can edit things like the idle seconds before scale down and kind of edit the minimum and maximum number of nodes at any time. In the UI or using the SDK or CLI as well. With SSH, you can click here to connect. This will pop you over to the Nodes tab here. In this case, my cluster is completely scaled down, but under this Nodes tab, when it's spun up, you'll see kind of the available nodes here. So you would see two nodes with the IP addresses that you can use to SSH into those nodes for further debugging. And as you're creating your cluster and triggering a job against it for the first time, you'll see the cluster. You can kind of monitor its state, from this panel here, um, and you can see things like all the jobs that have been triggered against the cluster, and you can also go over to this monitoring tab here, which will allow you to kind of drill down into specific metrics on GPU cluster utilization, cluster health, IO, and all the kind of disk metrics as well through here. So you can run that over, say, any kind of specific interval. So maybe for debugging purposes, you just want to really drill down into jobs over the last hour, for example, or day, for example. And with that, that concludes kind of our demo on creating a compute cluster to utilize your Microsoft for Startups dedicated GPU cluster allocation. With that, happy building. And in the next series of demos, we'll get into how to trigger jobs against this cluster.